What is a hypothesis? In this case, a lot of people describe a hypothesis as an educated guess. In other words, they'll see things out there. They will say, well, I think it's going to rain today, or I think that we're going to have a recession. So based on their hypothesis, they may have to explain or guess why they may be correct. It is basically a suggested solution to things that happen in the world. Also, there's no predetermined outcome. I think it's going to rain today. That's just a thought. For a hypothesis to be termed as a scientific hypothesis, we have to have the data to support what we are observing. In most cases, we write a hypothesis as an if-then statement. In other words, if something happens, then the possibility occurs. For example, if the price of gas goes down, then more people will travel by car. But what we want to consider in our case is a statistical hypothesis. And along that, we want to consider a hypothesis test. So what is a statistical hypothesis? A statistical hypothesis is a claim or statement about a population parameter. We have talked about population parameters so far in this course, and some of the population parameters that we have talked about include the population mean, the population variance, the population standard deviation, the population proportion, and the population size. A hypothesis test is where we take information, put it through a statistical process called a hypothesis test to test the claim about the population parameters as previously discussed. The main objective that we're going to consider in this lesson is the ability to conduct a hypothesis test for claims made about a population proportion, a population mean, or a population standard deviation. However, in this case, we will not cover the population standard deviation. A word of caution. When we talk about hypothesis tests, we don't want to just jump into conclusions thinking that, okay, all my data points suggest that we have a high rate of failure. Well, no, that's not what we're trying to do. We have to take the data that we have collected and put it through a statistical process, and based on that statistical process, that will determine whether or not our hypotheses are supported or our hypothesis is not supported. We also must include the sampling method on how we collected the data and the methods used to obtain the sample. Here are some basic concepts for testing an hypothesis. This is what we should understand. We should understand how to identify a null and alternative hypothesis from a given claim, and we should be able to express them in symbolic form. We should also be able to calculate the value of the test statistics, and we have done this before. We will be using some of the same equations that we have used before. We'll also understand if the sampling distribution is relevant. In other words, we've already looked at cases where we had to use a different distribution based on whether or not we know what sigma is or the size of the sample. We're going to talk about p-values, and p-values we will learn to understand that these are things that we've already done when we looked at the normal distribution and in our practice and understanding how to manipulate the normal distribution. And we're going to be able to state conclusion about the claim in simple and non-technical terms. Well, how do we do this? In this introduction, we're going to talk about the 5 steps for hypothesis testing. Step 1, we're going to state the null and alternative hypothesis. And in doing this, we're going to also identify the claim. We're going to look at what we call the level of significance, and we call the level of significance alpha. And we've already been introduced to the term alpha, and we know that alpha is what is left over from our confidence intervals. So if our confidence level is 90%, we know alpha is what's left over, which is 10%. If our confidence level is 95%, we know that alpha is what's left over, and that is 5%. So in essence, if we really look at what this is saying, alpha represents what we call our risk factor. In other words, if I'm 90% confident that something is about to happen, or my confidence level is 90%, then I'm really willing to take a risk of 10% that I am wrong. So we will look at alpha as our risk factor. Also in step 2, we want to draw the picture based on alpha and determine our critical values. In step 3, we want to compute the test statistic. And again, we have seen the test statistic before, and it should be no surprise as to the pieces that we're going to use to put into our puzzle so that we can understand how to compute the test statistic. Step 4, we're going to compare the test statistic value with the critical value. An alternative method that you're going to be introduced to is the p-value method. And with the p-value method, we are going to get the same results that we will get using the test statistic method. And finally, our step 5, we're either going to reject or fail to reject the null hypothesis. Note what we're saying. We're only going to reject or fail to reject the null hypothesis. And then once we do that, we're going to make a statement about the problem at hand. Additionally, we're going to also state whether or not the claim is supported or denied. So this is what we're going to do. This is the introduction. We will begin the next video on the 5 steps for hypothesis testing, and we will discuss step 1.